Lavoisier didn't just study chemistry, he revolutionized it by applying the meticulous precision of a ledger to the chaos of the laboratory. By introducing the law of conservation of mass, he transformed science from qualitative observation into a rigorous quantitative discipline. However, this same obsession with accounting, his dual life as a royal tax collector, eventually cost him everything. This presentation explores how his drive for systemic order fueled the chemical revolution, but ultimately led to his tragic end during the Reign of Terror, proving that even the most brilliant discoveries are inseparable from the political structures that fund them. Lavoisier's genius was his refusal to accept approximate truths. In the lab, he tracked every grain of mass, proving matter is never lost, only transformed. This transformed chemistry into a precise science. Yet, he applied that same uncompromising exactitude to the state, tracking every coin of tax for the Ancien Regime. While his ledger-driven mind birthed a scientific revolution, it also made him a visible symbol of systemic oppression. By understanding this duality, we see that his greatest strength was also his fatal flaw. He could account for every atom in a reaction, but he failed to calculate the rising heat of a social revolution. Before Lavoisier, chemistry was a sensory art, blinded by the mystical belief in phlogiston. By moving from the eye and nose to the exact weight of the balance, he replaced vague philosophy with a rigorous quantitative framework. He dismantled the ancient four elements and introduced an expanding list of unbreakable substances. Crucially, he proved that burning wasn't the release of a mythical fluid, but the absorption of oxygen. This paradigm shift didn't just add new knowledge, it redefined the very nature of scientific proof, providing the foundation for every chemical breakthrough that followed. For decades, science was trapped by the phlogiston illusion, assuming combustion was a process of subtraction. Lavoisier broke this spell using the ultimate arbiter of truth, the balance. In his 1772 experiments, he proved that burning sulfur and phosphorus didn't release a mythical fluid, it absorbed something from the air. By showing that the resulting calyx weighed more than the original material, he turned chemistry from a story of loss into a law of conservation. This wasn't just a new discovery, it was the moment chemistry gained its modern eyes, trading subjective observation for the undeniable outcomes of quantitative reality. The chemical revolution wasn't a solo act. It was the product of a powerful intellectual merger. In the Arsenal laboratory, Antoine's theoretical brilliance and experimental designs were given life by Marie-Anne's meticulous records and engravings. She acted as the bridge to the international community, translating critical English texts and illustrating the very instruments that proved their theories. This collaboration ensured their findings weren't just discovered, but widely understood and adopted. By recognizing Marie-Anne's role, we see that the birth of modern chemistry required more than just an accountant of matter. It required a world-class communicator to turn localized data into a global scientific standard. Lavoisier silenced the alchemical dream of spontaneous creation by enforcing a strict universal balance sheet. By isolating reactions in closed containers, he captured the invisible, the gases and vapors that previous scientists ignored. This demonstrated that while the form of matter changes, from solid wood to ash and smoke, the total mass remains identical. This first pillar transformed chemistry into a science of accountability. It moved us away from mystical transmutation and toward a reality where every atom must be accounted for. By proving that matter is immutable in quantity, Lavoisier provided the essential law that governs every chemical equation used today. The discovery of oxygen was a duel between observation and interpretation. Joseph Priestley was the first to isolate the gas, but he remained a prisoner of the old phlogiston theory, viewing the air as a passive container for mythical fluids. Lavoisier, the scientific radical, realized the gas was an active chemical participant that united with combustibles. While Priestley discovered the gas, he misunderstood its nature. Lavoisier gave it a name and a function, dismantling the phlogiston era forever. This pivotal moment proves that in science, seeing is not enough. True progress requires the courage to build a new paradigm that matches the data. Lavoisier recognized that science cannot advance if its language is deceptive. Before 1787, sugar of lead invited accidental poisoning, while dephlogisticated air masked the true nature of oxygen. By partnering with Guiton de Morveau, Berthollet and Fourcroy, Lavoisier replaced alchemical mystery with structural logic. Names were now dictated by the substance's root elements and chemical makeup. This wasn't just a rebranding, it was the creation of a universal chemical grammar. By standardizing what we say, Lavoisier ensured that a chemist in Paris and one in London were finally speaking the same language, paving the way for the collaborative era of modern science. Lavoisier didn't just rename chemicals, he engineered a language that could predict the future of a reaction. By creating a nomenclature root tree, he made the underlying chemistry visible. If you know a substance is sulfuric versus sulfurous, you immediately understand its oxygen state and how it will behave. This systematic clarity did for chemistry what biology's taxonomy did for life. It organized chaos into a logical hierarchy. By standardizing these roots, Lavoisier turned language into a laboratory instrument, allowing scientists to deduce the properties of a substance simply by hearing its name. This was the moment chemistry became a truly mathematical and predictive science. Lavoisier's greatest triumph was not a single discovery, but the unification of science. By binding the rules of mass, the mechanism of oxygen, and a logical language into the first modern chemistry textbook, he provided the world with an enduring operating system. He replaced fragmented observations with a cohesive, predictable framework that any scientist could follow. This chemical revolution transformed a chaotic collection of facts into a rigorous professional discipline. Though his life as a financier ended in tragedy, his legacy as the accountant of matter remains the bedrock of our physical world. He didn't just win a scientific revolution, he built the tools that would define every revolution to follow. 1789 was the year Lavoisier won the future but lost his life. As his masterwork transformed chemistry into a modern discipline, the French Revolution transformed him into a target. The same meticulous precision he used to track atoms was used to collect state tolls, turning his greatest intellectual asset into a political liability. His 1790 quote reveals a heartbreaking awareness. The state of public affairs was no longer just a distraction, it was a force that would eventually halt his progress forever. This conclusion reminds us that science does not exist in a vacuum. Even a man who could master the laws of nature could not escape the volatile reactions of a society in revolt. In the end, Lavoisier's meticulous bookkeeping could not save him from a ledger balanced in blood. His commitment to scientific rigor had earned him a powerful enemy in Jean-Paul Marat, whose amateur theories Lavoisier had once dismissed. When the revolution demanded a scapegoat, his role as a tax farmer provided the perfect pretext for arrest. Lavoisier attempted to defend his life by citing his service to humanity, but the court's infamous reply, "The Republic has no need of scientists," sealed his fate. This tragedy marks the moment where the precision of the laboratory was silenced by the chaos of the guillotine, proving that even the most transformative discoveries remain vulnerable to the political storms of their time. The precision Lavoisier brought to the laboratory was met with the cold, mechanical efficiency of the guillotine. On May 8, 1794, the accountant of matter became a victim of a system that valued political retribution over scientific progress. In just one day, the man who codified modern chemistry was tried, executed, and discarded. Lagrange's epitaph serves as a stark reminder of the cost. It takes only a moment to extinguish a brilliant mind, but a century may not be enough to find its equal. Lavoisier's life ended in an unmarked grave, but his three pillars continued to support every laboratory in the world, proving that while a head may fall, a revolution in thought is immortal. Even in death, myths attempted to turn Lavoisier into a caricature of his own scientific method. The popular story of his final experiment, blinking after the blade fell, is a modern fiction that collapses under scrutiny. There is no reputable evidence for this event. Logistically, the chaos of the Place de la Révolution made such an observation impossible. By debunking this myth, we honor the real tragedy. His death was not a scientific triumph, but a swift, brutal, and utterly unscientific end. We must value the authentic pillars of his life, his actual contributions to chemistry, rather than a fabricated legend. True historical legacy doesn't need folklore to prove its brilliance. Lavoisier's execution was a momentary victory for political chaos, but his intellectual legacy proved invincible. By gifting science its first true operating system, he ensured that chemistry could never return to the shadows of alchemy. Today, every time a scientist balances an equation or uses a systematic name, they are utilizing the pillars he built. His tragic end serves as a powerful reminder. While a regime can destroy a scientist, it cannot unmake a universal truth. We don't just remember Lavoisier for how he died, but for the clarity he left behind, a world where matter is accounted for, understood, and transformed for the benefit of all humanity.